All right, let's talk about section 12, translations of functions. So translations of functions are rigid movements, meaning the shape of the graph stays the same, but it can move around the graph. And this can be horizontal or vertically. Okay, so for example, 1, if we see something happen outside of the parentheses, we know that it's going to be a vertical. And if it's adding or subtracting, this is a shift. So if I see a vertical plus, that means an upwards shift up 4. So that means I'm going to take every point on my graph and I'm going to shift it up 1, 2, 3, 4. And we're going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We're going to recreate that graph. Okay, so this is f of x plus 4, which is f of x shifted up 4 vertically. All right, let's look at this one. So this one says f of x plus 4. So this is inside the parentheses. Anything inside the parentheses is a horizontal change. Because it's plus or minus, it is a shift. For anything inside the parentheses, I call this funky town. So anything inside the parentheses is horizontal, but it's also funky. And we call this funky town because it's the opposite of what it seems. So plus 4 would usually tell us, hey, we're going to the right 4. Because it's funky town or horizontal, it's the opposite, which is actually going to be to the left 4. So I'm going to take every point and I'm going to shift it to the left 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So we see this is f of x plus 4 in the parentheses. That's a horizontal shift to the left. All right, let's look at this one. Again, this is outside the parentheses, therefore it's a vertical. It's subtracted, so it's also a shift. And because it's a minus, we say down 4 units. So every point goes down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, and so we're going to see that where this is f of x all minus 4. That's a vertical shift down 4. All right, let's look at this one. It says, hopefully you can tell, since it's inside the parentheses, we know this is a horizontal shift. Because it's plus or minus, it is a shift, but it's the opposite of what it seems. So minus 4 would typically go to the left, but this is going to the right because it's funky town in the parentheses. So every point's going to go to the right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on. So we see something that looks like this. And this is f of x minus 4. Horizontal shift to the left 4. All right, so let's look at what happens when we, again, outside the parentheses tells me it's vertical. Multiplying by a negative is a type of reflection. And if I'm vertical reflection means it's going to reflect over the x-axis. So if this is the x-axis, imagine this is a mirror, and everything's going to reflect vertically. So at this point here, since it's 3 above, it's now going to go to 3 below. This point here is on the x-axis. This point here is 2 above, so now it's going to go 2 below. And this one's on. So we're going to go ahead and connect those dots where we say this is the g of x, which is the vertical reflection of f of x. All right, let's put it all together. So a couple things. Remember, we see a vertical reflection across the x-axis. We have a horizontal shift to the right because it's the opposite of what it seems by 2. And this is a vertical shift because it's being added and it's going up 5. So we're going to do all of these, okay? All right, so we're going to flip it first, okay? So I know I'm going to flip this upside down first. So this is our, let me put this color coding. Whoopsie, our vertical flip like this. And then we're going to go shift to the right, so by 2, so over the, everything's getting shifted to the right. Okay. So it looks something like this. And then we're going to go up by 5. So everything goes up 1, 2, 3, 4, 5. Here's like this. And this point here is going to go up 1, 2, 3, 4, 5. Okay. So we go like this. Okay, let's talk about what does this look like algebraically. So if I'm looking, if this is f of x, g of x is f of x adding 4. So if g of x equals f of x is x squared minus 3x plus 2, all added by 4. So I'm just going to simplify what I have here by taking off the parentheses because there's no distribution needed. And we're going to add like terms, which is a total of 6. So our g of x is x squared minus 3x plus 6. Algebraically also, so if f of x is x squared, how do we find f of x plus 4? So that means g of x is every time I see x, I'm going to replace it. Whoops, this is supposed to be 3. I'm going to replace that x with this, x plus 4. And so we go x plus 4 squared is x plus 4 times x plus 4 minus 3 times x plus 4, so that's 3x minus 12 plus 2. FOIL this out. X squared plus 4x plus 4x plus 16. So now we're going to combine like terms x squared plus 8x plus 16 minus the 3x, bring it down, minus the 12 and plus the 2. Combine like terms, we get x squared positive 8x minus 3x is positive 5x. 16 minus 12 is 4 plus 2 is 6. So g of x is there. Let's look at this numerically. So numerically, we can also see this by plugging in a specific value for x, okay? So if I want to find g of 2, instead of x, I'm going to replace it with 2. So that's like saying f of 2 plus 2. Well, using this chart, I know when I input 2, I get out, this is f of 2. So f of 2 is 10. Add the 2, we get 12. So g of 2 is 12. Same thing here. If I want to find g of 4, remember I'm going to replace 4 with any time I see x. So f of x, which is 4, minus the 2 plus the 1. So let's simplify this. Well, I know 4 minus 2 in the parentheses is just 2. F of 2, so I input 2, I get out 0. That's 0 plus 1, which is just 1. All right, so let's do this a little bit more challenging idea of how things, translations, can change a domain or range, or transformation can change a domain or range. So f has a domain of -4 to 3. In a range, we'll write the range right here, from 3 to 9, not including. G of x is a vertical flip, a horizontal shift left 5, and a vertical shift up 2. So let's talk about what's what. We know the domain describes the x values. So if the domain is describing the x values, it also is telling me this would change by any kind of horizontal changes. Where do we see horizontal changes? Well, we only see horizontal change here, shifting everything left 5. So imagine if I shifted this -4 to the left 5. So how would I shift everything to the left 5? I would literally take away 5 from everything. So instead of -4, it'd be -4 minus 5. Instead of 3, it'd be 3 minus 5. So if I simplify that, this is just going to be -9 to -2. So that's my transformed domain. So for the range, remember, these are the y values, which will be changed vertically. So anything vertical is going to change it. So I've got two things. I have a vertical flip that's going to change it, and a vertical shift up 2. So let's do the vertical reflection first over the x-axis. So I want you to think about if something is over the x-axis, it goes from being positive to negative or negative to positive. So if this is positive 3, if I flip it over the x-axis, it will now be negative 3. And if this is positive 9, it will flip over the x-axis to be negative 9, okay? Now, if I do a vertical shift up 2, that's like adding 2 to each of these values. So instead of negative 3, I'm going to add 2. Instead of negative 9, I'm going to add 2 as well. So we end up with a new range from negative 1 to negative 7. But remember, this range always has to go from least to greatest. So instead of negative 1 to negative 7, because of that flip, we have to switch things around. So it goes from negative 7 to negative 1. And there's our new range. See you next class.